Good afternoon. It's my pleasure to give a lecture here in the open course in Hong Kong. Now, today I will, in an hour, to briefly introduce 5 physiological models of Mandarin from the top to the bottom. That means first I will introduce a model of lips.可以吗？好像声音还是很小。
你可以夹到你的领子上。
不是那个问题。喂，哎，
那不是很敏感这个。
是能听到吗？好，
这个也许夹到你这个。
按说不应该。
这个
First, I will play a video in Mandarin, the standard Mandarin. ，From the video, you can see the shape are quite different. Our problem is how to modeling the shape of the lips. Now, usually in the speech engineering studies, they use the out contours of the lips to definite the lip. You see, you can use a program to automatically, very quickly. I mean, in the real time. So you maybe from the materials you can find the person, or sometimes you can use these parameters to enhance the speech recognition. Now from here you can see the use the width and the height, the different height to definite lips. But in many times we found it cannot be used to explain the to explain something like the round lip or unrounded lip. So we developed the definition. We use 2 contours of the lips. One is the inner contour of the lip, and another is the outer contour of the lip. By using this, we set up a model, and then by using this definition, we extract the parameters from the real video. Now we use the method to localize the position and how to get how to extract the parameters of the lip from a video. Now here I show you analyzing platform. We set up a program to extract the parameters of the lip. Now from here we can see this is a video, the part of the lip. There are many function buttons here. You can use this to extract parameters. Now here we show 3 parameters like this, and this is the speech sound. Now, by this platform, we set up a large-scale database of the lips in Mandarin. I will show you an example. Now see here. At the beginning, I showed you the sample of the video, and now we extracted the parameters from these videos. And now we are writing a book to explain all the lip parameters. We try to find the features or characteristics between the lip and the speech sound. Now, from here, you can see we set up a model. By this model, we can synthesize all the Mandarin lip movement like this. Now, I will show you an example. Now, they are all techniques. After we finish the model, we establish the model, maybe people will ask what's the use of it. Now, I will show you 2 examples. Now, see the first. Watch this video. Once more. Can you tell me the sound? What syllable?
最高。
What's the syllable? Who can tell me the syllable? Yeah. Okay. Now listen it. Close your eyes and listen. When you watch the video, you maybe hear da, and when you close your eyes, that's fa. Now next. And then close your eyes. They are the same sound. They are all ba. The sound is ba, but here the video is da. Here the video is da. We watch and listen it. You get the da, the difference. Now I will show you more examples. This is the ba group. Okay, next. When you watch the video, you hear the different sound. but they are all the same syllable. Now the D group. What the sound? Something like the consonant cluster, but da. No. Now next. This is da. From here we can see the video is da and the sound is da. You still heard the sound is da. But here the video is ba. Here the sound is da, and you hear da. Now I will see another one. We delete the inner contour of the lip, inner lip. Now next. By our system, we can synthesize quite different samples with only the outer contour of the lip or the inner contour of the lip. So you got different samples for the perception study. You will find it's very interesting. Yeah. Now synthesized group here. Only the outer contour. Do you think the different? Now from here we can see the video is ba and the sound is ga. You have heard ga. The video is ga and the sound is ba. You heard da. And the video is ba. The sound is ga. You heard ga. And the video is ga. The sound is ba. You heard da. It tells us it is a famous microwave effect published many years in Nature. Now we have studied we use our lip model to study the detail. We study the detail of the lip movement, and then we can use this model to synthesize quite different samples. Just as I said, only the outer contour of the lip, or only the inner contour of the lip, maybe you can find quite different results. Just now I just presented you the 2D model of the lips. Now we are establish the 3D model of the lips by the motion capture, a new instrument. Now see, here is a definition. And I will show you one example how to sampling the speech sound and the video. Okay. When we get these videos or parameters, we have to set up a program, or we set the analyzing platform to extract the parameters and analyze them. And by using these materials, we can set up the model. Now here I will show you one example.
我看见过波澜壮阔的大海，玩赏过水平如镜的西湖，却从没看见过漓江这样的水。
Now, you know, in China there are many child with hearing problem. They have to choose a very special primary school or high school to learn the lip reading. Sometimes they said it's the speech reading, part of the speech reading. So by the system, by the model, we can set up the learning system for these children to learn the lip reading. You hear.
啊啊呜呜
Now we change. There is no sound. I don't know whether you can distinguish the two syllables wu and yu. It is a little bit difficult for the normal people, normal Mandarin speaker. But we have a test to ask the student in Peking University to have, maybe have, let me see, 10 hours training, and they can read it very well. They can. So I think by using these models, we can establish a different learning system for the people who have the hearing problem. Yeah. That's the first one. Now next, I will briefly introduce the model of the vocal tract. Sorry. According to the acoustic theory, we know the speech system can be divided into two parts. One is the source, another is the vocal tract, the resonance. In linguistics and phonetics, we usually call the resonance of the vocal tract articulation, and the source is formation. Now see this video here. This video is taken by the X-ray, but now we cannot do such experiment because it's very dangerous, can hurt people. Now, with this materials, the X-ray materials, we set up a program to analyze the X-ray video, and here from this you can see the lips, the contour of the lips, the tooth, and the vocal tract, and here is the area of the vocal tract. So we have got about more than 20 vocal tract area. by this area, we can synthesize quite different sound. Now, this is the X-ray image processing platform. By this platform, we have analyzed all the syllables of Mandarin. This is X-ray video. This is a parameter, or we say the video created or produced by our model. And here is the parameter. This is the speech sound, and here is the spectrum. Finally, we have got a large database of this video database. This is model. Now from here, you can see the parameters here. There are 12 parameters. With these 12 parameters, we can synthesize a whole vocal tract. This is the area here, the area of the vocal tract, the different area of the vocal tract. This is the spectrum calculated from the area of the vocal tract. And using this spectrum, we can synthesize the speech sound here. This is the spectrogram. You see it? Depends on the large database. We have first set up a very small program for the Mandarin teaching, the pronunciation teaching. You can see, and it's an initial here. All the video here, you can see the articulation here. Final. This small book will be soon published in Hong Kong U. Now, next I will show you the 3D study of the vocal tract. Now, you know, the MRI machine is very popular now, and maybe in every hospital they have one. So we use the MRI machine to sampling many Mandarin samples. We have got a large database, including 8 persons. This is the method how to scan the vocal tract. By the MRI image, we can see the inner structure of our vocal tract or the different organs, the speech organs. The video, how to pronounce the vowel here. You see, by this method, we can get the real 3D vocal tract. By this method. Now, this is a platform we have set up for the analyzing of the MRI images. Now, here is the original image. This is the parameters we have got and showed by our model. This is speech sound. Here is the spectrogram, and here is the area of the vocal tract. The different area of the vocal tract is a parameter here. Now I will show you an example. Now, up to now, because of the speed of the MRI machine, it's very difficult to get the video. I mean the video of the vocal tract, the movement of the vocal tract. If you want to get 3 syllables like this, you have to pronounce more than 200 times. So you got only one sample. And the sample is not very clear because every time they can scan only one slide of the vocal tract. Now here I will show a very clear example here. This is the upper lip, the lower lip is the tip of the tongue. Right here. Here is the root of the tongue. This is our target, and not finished yet. Yeah. So I will try to get more database, to increase our database, to get more samples by the MRI, so we can finally set up a model of the vocal tract, or we say the articulatory model of Mandarin. I think this Mandarin can be used in many places or field for the language teaching, or especially we want to set up a system which has we call the speech sound feedback to the vision, the video system. So when you speak to a microphone, and there will be a vocal tract movement. That's our final target. Now, there are many different models about the articulation model. This is the acoustic speech model. The very famous model was established by Gunnar Font. And the geometric speech model, now our model belongs to the second one, the geometrical speech model. And in the recent 10 years, only several universities in American and Japan and French, they study the physiological model to set up the model by establishing different muscles. And I think that all the people who study it is the force, the final target. That is, people want to establish the neural speech model that uses the neural signal to control the movement of the physiological mechanism, and then finally to produce a speech sound. Thanks. Okay. Oh, sorry. This is a study on the voice of Mandarin through high-speed imaging. Our vocal fold vibrates very quickly. So it's very difficult to get samples. Maybe in the 18th last century, there is the people developed the techniques of the high-speed imaging. By using the high-speed imaging, we can get the samples to see the vibration of the vocal fold. And also, there is a story that means in the ancient time, that people know the difference of the vocal tract and the formation. Maybe later you can find it to read. It's a very interesting story in the 孟虚笔谈by Prof. Now this time we have no time to. Here is the video camera, the high-speed video camera. You see the subject, and we also use the laryngograph to get the EGG signal. I mean the sound, the voice signal simultaneously. This I'll show you four samples here of different tones. Is the first tone, the high level tone. Maybe some. You can see the change of the glottis or the length of the vocal fold. It's very low here, you can see. The four tones in Mandarin. When we take the sample, the sampling rate is 2,000 per second. 2,000. We play it very slowly. After that, we have to do many very complicated signal processing. Here we mean the image signal processing. Now here is a moving compensation, because they move very quickly. The lens move very quickly. So we have to do the moving compensation here. And then to get the track here. This is the result. The before the image processing and after the image processing here. Get much better here. And then we have to do the contrast adjustment. You see, this is the original image, the video original. You see the glottis already been detected. And then finally get the glottis. After that, we have to give a definition. By using this definition to extract the parameters of the glottis, the dynamic glottis. Now here we give, we mainly the 13 parameters is very useful. This is the model, is a sample of model voice. And all the parameters here, the 13 parameters. Now we have the left width of the glottal area, anterior length of the glottal area, and also we have the open quotient, the speed quotient, and of course we have F0, the fundamental frequency. Yes. Now here I will show you some examples. Maybe you are very interested. This is a model voice, and all the parameters here. This is a falsetto. When people want to sing a very high voice, they usually use the falsetto. The vocal fry is a typical vocal fry. Okay. This is a very special vocal fry. You see the period is not very regular. They have the double pulse. The double pulse or 3 pulse in each period. This is a aggressive voice. This sound is very special. Many people can pronounce this voice. That's diplophonia. Diplophonia means one person, they can control the muscle of the glottis, the muscle around the vocal fold. And one vocal fold vibrates quickly, and another maybe not very quickly. So they can produce the sound of the diplophonia. Like this. By this method, from the parameter you see, by this method they can produce a very large period. In this period, it contains maybe 5 or 6 small periods. It can be used in the singing or the chanting, something like that. This inspiration. By this system, we have extract the parameters of the 4 Mandarin tunes. We usually use 3 parameters. Of course, the first one is F0. The second one is open quotient, and the third one is the speed quotient. Now from here we can see this is F0, this is speed quotient, this is open quotient. If you only use one here, F0, you cannot synthesize a very natural speech sound. At least you have used 2 parameters. Of course, we can also add the jitter and the shimmer to increase the naturalness. But the basic 3 parameter for speech synthesis is F0, open quotient, and speed quotient. According to the parameter database, we have established a model, I mean the dynamic glottis model, to synthesize the speech sound from the glottal area to the speech sound. Now this, I will now say about the techniques. Now here, the model, the definition here is, this is a glottis. We use here, the static glottis was modeled by the 4 quarters of ellipsis. And this is the modeling of the, we call the control, the speed control. We have to use 4 functions to control the movement of the glottis. With this parameter, with this model, you can edit the parameter in the Excel and then synthesize the speech sound very quickly. Now here, I just to show you an example here. You listen this sound. You know, in Mandarin, we have the lower tune, and the second tune. Okay, I will show you more. I synthesize the 4 examples for the 4 tunes. This the tune was synthesized by the area, not the speech sound. Only the glottis, I mean the glottis to the speech sound. So it's a physiological model, not acoustic model. Now here, I show you another example. With this model, we can study the perception of the speech sound. We also can study the perception of the tunes. By this physiological model, we can synthesize quite different samples. Now here, you see this one is, the blue one is F0, and the red parameter here is open quotient, and the green one is a speed quotient. From here we can see the speed quotient increased very quickly. Now listen to the sound. So what the change you heard is the speed quotient. How do you think about the pitch? A little higher or constant? I will play it more. It seems the pitch have a little increase, higher, a little higher. But actually, here you see the parameter here. Now, another example, more interesting. Now here, we can synthesize the speech sound in quite different ways. Now here we change the spectrum. You see, this is the spectrum like this. And here, you know, the people can pronounce very low voice, or in the prophecy, they change the pitch very quickly. In many times, people use the subharmonics to produce the sound. The harmonics, something like this. You see, the subharmonics like this. But you see the sample. Maybe the first one is lower, the second one is higher. You see. But the parameter tell us here, the F0 are the same. So it tells us the F0 is not the pitch, are quite different. They are quite different. Before we finish this, I will show you something. You see, it can synthesize a voice. I can change the spectrum like this. You see, there is one F0. Of course, you got a pitch, a constant pitch. But when I change the spectrum, you can hear two pitches. Can you hear? This is Humai. I don't know whether you know. It's oral culture, one kind of very special oral culture by Mongolian people. So there are two pitch. So it's very easy for people to pronounce two pitch at the same time. And also you can change these two pitch. One is produced by the vibration of the vocal fold, and another is by the resonance. Maybe next we can do some testimony by ERP to see that whether the difference in the perception. I don't know. But we also can synthesize more harmonics like this. If you give 2 or 3, you cannot hear the different pitches but vowels. Okay, I will finish this part. But I think the time is. 没有时间，还有后面。Okay. Yeah, I think the time's up. Another two, maybe people are very interested about the lung model and the breathing model and the model of the Chinese people, how to assessment the voice of you. I mean, everyone, we have set up a Mandarin model for testing or assessment the voice. The normal or irregular or disordered voice, we can use our system to test it. Not this time, I think. Maybe questions.
Okay, yeah, let's take this opportunity to ask. Any questions? Okay, obviously.
Great talks. I have one question. That is, from your experience, can subject judge a lexical tone just by the visual expression of the speakers? Like, we can judge consonant like fa and da from the lyrics, but because tone is basically based on vocal voice, so from the visual expression, we judge the tone that is being pronounced.
You mean from the visual?
Any visual cue.
Yes, it's very difficult. But from the parameter, we can find some, maybe there's a movement on the larynx ear, a movement. And people, maybe their head has a little movement, but it's very difficult.
Yeah, please.
Thank you very much. I like the 2D lead model very much.
Oh.
The 2D lead model. Yeah, because I found that it's actually very useful for the special needs students.
Yeah.
But have you ever do practicing, real practice on the special needs students yet?
No. but very busy with the basic study and cannot get money to do the education.
It should be very useful.
Well, I try to establish the learning system for the children who has a hearing problem.
More questions?
Okay.
Okay. So yeah, given the time, let's move to next talk.